Hey, Dr. Romano, it looks like you've got another video on the board.
Yes, I'd like to go over a problem with you that my entire study group was eviscerated on. Very disappointing. I thought it was a pretty easy question and I was being super magnanimous. Let's have a look.
Okay.
We have two liquids, liquid X and liquid Y. Liquid X has a density of 13,600 kilograms per cubic meter, and liquid Y has a density of 800 kilograms per meter cubed. If the masses are equal of these liquids, what is the ratio of the volume of liquid Y to the volume of liquid X? All we would simply do is write the formula for density. Density equals mass over volume. This is the density of X. That's the volume of X. And I write it again. We're going to have the density of Y, forgot the Y, sorry. Density of Y equals mass over the volume of Y. Or, if you cross multiply, dx, vx is m, and we said the masses are equal, so dy, vy is m. Since they're both equal to m, we simply set them equal. Dx over dy is vy over vx. Plug and shove. We know dx, 13,600. We know dy, density of y is 800. And that gives me 17. And that 17 represents the volume of y to the volume of x. Or, as I said, the ratio of the density of x to the density of y. Here I want the ratio of the volumes, so it's 17. So if we rewrote it, vy over vx is 17 over 1. So the ratio is 17 vy 1 for vx. I hope that gives you an understanding of how to do density problems other than just plugging it in to a silly formula, D equals M over V. Remember, density and volume are indirectly proportional because if you look at the formulas and you cross multiply, you can see they're on the same side of the equation.
That's some really good work, Dr. Romano. If I know how to do that problem, will I get a 30 on the DAT?
Probably not, but it'll give you a start. Maybe you'll get a 1 on the DAT. Good day to you.
Sheesh, Dr. Romano, you're awful hard. Good day to you, sir. I'm going for the 30.